if a system is isolated on which there is no force acting on it, then if you apply any action to any one of body, it will produce a reaction to opposite, and action and reaction must be equal to each other. So you'll say for every action, there is equal and opposite reaction. And since this action and reaction acts on two different bodies, so they will never cancel out each other. Since action and reaction acts on different body, so never cancels out. Is it clear till this part?
Yes, sir.
Okay. Now, for this third law, we first define about normal reaction. Normal reaction is a force by the surface perpendicular to it. So, a force on a body perpendicular to its plane is termed as normal reaction. Suppose you have a block and another block, they are placed adjacent to each other. So if block A apply force on B, so it will be along this direction. In return, block B will tend to apply a force in opposite of it. So these two forces will be action and reaction. And since it is at the interjunction of two surfaces in contact, so these forces are perpendicular to this plane of surface. So we can say these are normal reaction between two bodies, A and B. Is it clear? So this force will be force on B by A, and this force on B, A by B, are normal reaction at the junction of A and B. Similarly, if you have a block placed on horizontal surface, now if block having mass sum m, due to which it will be attracted towards downward direction by gravity, let's say mg. So this block will applying this much amount of force due to its weight on this horizontal surface. So in return, this surface would applying a force to balance this in upward direction or perpendicular to its surface. This force will also called as normal reaction. So normal reaction is basically a force which is perpendicular to plane of the surface in contact of any block or surface. Okay. Okay, just write it down till.
Done, sir. Done, sir.
We all have written? Sabita?
Done, sir.
Safan?
Done, sir.
Now, how to solve these type of normal reaction for any combination of system or bodies? Suppose you have block A, block P having mass 3 kg and 2 kg. There is a force along this direction, suppose 12 Newton, another along this direction, 2 Newton. So find normal reaction in between two bodies. So for any problem, first try to find acceleration of system. Just 1 minute. Suppose in this part, we have two block system. So first try to combine them to behave like a single body system. So it will behave like this. So total mass of this particular system will be 3 plus 2, that will be 5 kg. Now draw all forces acting on it. So one is along this direction, 12 Newton, and the other is along this direction, 2 Newton, in which 12 is stronger as compared to 2. So due to this 12 Newton, there will be some acceleration to the system along larger force. So it will be acceleration of system. So just apply Newton's second law. Acceleration of system equals to net force divided by total mass. So we have net force. First is 12 Newton along right side and 2 Newton opposite of it. So minus of 2 divided by total mass of system is 5 kg. So 12 minus 2, 10 divided by 5 equals to 2 meter per second square. So for any problem, first try to find acceleration of system by taking whole combination as single lump of system or body. Okay.
Yes, sir.
Now, try to define FBD for each block. FBD means free body diagram. Free body diagram means a representation of all forces acting on that particular object along or opposite to the direction of its motion. So FBD is nothing but a representation of all forces acting on body in or opposite to its motion. So for free body diagram, if you draw for A, which must be acted upon by 12 Newton from left hand side. And since A would apply some amount of action on B, so B in return will apply some of its reaction to A. So it will be force on A by B. Now, as the whole system is going along the right hand side with some acceleration A, so in a system, all body or block would move with the same velocity and having same acceleration. So as we have calculated acceleration of system, this would be common for each body. So for A, having mass 3 kg, a 12 Newton from left hand side and a force due to reaction of B along left hand side or direction along left will be acting. And In combination, net effect of this whole forces will be along right hand side direction. So use second law in this part. Acceleration of system equals to net force, that is 12, minus reaction of B, that is FAB, divided by mass of block, that is 3 kg. Put the value of acceleration of system, that is 2, into 3 equals to 12 minus FAB. So on solving, you will get FAB equals to 6 Newton. Is it clear?
Yes, sir.
Similarly, if you do the same process for block B, you will get the same action on B due to A. Let me define you. Suppose for block B, there will be action by A on B along this direction. There is a force from right side, 2 Newton. And since the whole system is accelerating along the right hand side with acceleration of system A, and mass of this block is 2 kg. So if you apply second law to this block as well, you'll get A system equals to force on B by A minus 2 divided by mass 2. Acceleration is 2, so 2 into 2 equals to FBA minus 2. If you move this 2 to other side, you will get FBA equals to 6 Newton. It means action by A on B equals to reaction on A by B. Is it clear?
Yes, sir.
Okay. Just write it down.
Done, sir.
Done, sir.
Done, sir.
Safan, you have written?
Yes, sir.
Aisha?
Done.
Okay. Suppose you have 3 block system. 2 kg, 1 kg, and 3 kg, in which a force along this direction of 15 Newton and along this direction of 3 Newton is acting. Let's say A, B, C. Find normal reaction between each. Use the above concept and try to find. First, try to find acceleration of system using second law, taking this whole system as a lump of bodies. Then draw FBD on each block and then apply second law to get normal reaction between each block. Good, Mariam. Just put all the values in these three different equations. For net acceleration, net force is 15 minus 3 divided by total mass 6. So 15 minus 3 is 12 divided by 6. So it will be 2 meters per second squared. Now put this in these equation. A is 2. 15 minus FAB we have to calculate, divide by 2. Similarly, in this part, acceleration is 2. FCB we have to calculate, minus 3 divided by 3. Samara, just check your calculation. Good, Samara. Good, Samara. If you simplify it, 2 into 2, 4. 15 minus 4 is 11. So FAB equals to 11 Newton. And if you simplify this, 3 into 2 is 6, plus 3, it will be 9. So force on C by B, it will be 9 Newton. Is it clear? Aisha?
Yes, sir.
Safan, any doubt?
So, don't we have to calculate for the middle block?
It will depend upon your choice. Let's say if you apply for the middle block, there will be a reaction from A. So force on B by A along this direction, and acceleration of B would be along this direction. And there will be a reaction force by C. So force on B by C. Force on A by B will be equals to force on B by A. So this will be 11 Newton. Now, if you apply second law for this block as well, which having mass 1 kg and acceleration A system. So you get A system equals to 11 minus FBC divided by 2. So 2 into 2, no, mass of this block is 1 kg. So 1 into 2, 2, 11 minus 2 is 9. So you'll get force on B by C is equals to 9 Newton. As we know, on same junction of two surfaces in contact, action and reaction must be equal. So this will be equals to force on C by B. You may use this way of calculating those normal reaction, or if you apply FBD on individual particle extrememost. Is it clear?
Yes, sir.
Now, the next concept in this part is to define tension. Suppose you have any support from which a wire, string, or a rope is hanged freely. So it will be like this, or it will have some slackness. So tension in this particular string will be 0 in this case. But if you apply or attach a block to this particular string, it will get straightened like this. So a force develops in a string, rope, or wire due to its straightness is called tension. Due to this block, which having mass m, there will be a force acting along downward direction, which will be responsible for straightening of this particular string, due to which a tension force will get developed into it. So you'll say tension is nothing but the force which develop in a wire, string, or rope due to its straightness is termed as tension. First concept is for massless, inextensible rope, wire, or string. Tension will be same at each point. Tension will be same at each point in entire string. Next is tension acts opposite to the point of contact. So it acts opposite to the point of contact. Let's say for this block, since I'm assuming this particular string to be massless, so tension at each point will be same. A block having mass m is attached to it, so there will be a force in downward direction mg. So from this point of contact, there will be tension in this string along this direction. There is another point of contact at its highest point, so there will be tension along this direction at this point. Is it clear? So this is how we draw tension into any string. Is it clear?
Yes, sir.
Okay.
Done, sir.
Done, sir. Done, sir. Done, sir.
Safan?
Yes, sir.
Okay. So for this string-based system, suppose you have 2 kg block attached with 1 kg block on which 10 Newton force along this direction and 1 Newton force along this direction is acting. So you have to find tension in this text. Find tension in the string. So first, use the above concept to find acceleration of system, taking all block to be single body system. So if we take these two block as single body system, so total mass would be 2 plus 1, that is 3 kg. There is a force along right hand side, 10 Newton. There is another on left hand side, 1 Newton. So the system will accelerate along this direction with acceleration of system. So just apply second law, you'll get acceleration of system. Try to find. Good, Mariam. Using second law, a system equals to net force, that is 10 minus 1 divided by total mass 3. So 10 minus 1 is 9 divided by 3 is 3 meter per second square. Is it clear?
Yes, sir.
Samaira,
So don't we have to take like minus sign for each because both are in opposite direction?
since forces are in opposite along left hand side direction, so take it as negative. So net force will be 10 minus 1. Okay.
Or can you repeat, your voice is cracking?
Since 10 is in larger in magnitude, which is acting along the right hand side, and 1 is in left hand side. So take 10 to be positive and 1 to be negative. So you have to calculate net force. So it will be 10 minus 1. Okay.
Yes, sir.
Now, as tension act opposite to the point of contact. So let's say for this 1 kg block, opposite to point of contact would be along this direction. So tension would be along this. And for 2 kg block, opposite to point of contact will be along this direction. Now, if you draw FBD, so 10 Newton along right side, and tension from point of contact along left hand side, as block is going along right hand side with some acceleration A. So use second law, you will get the value of tension. You may use 2 kg block as well. You'll get the same answer, as string is massless, so tension will be same at each point. So for 2 kg block, there is a force along left hand side, 1 Newton, and there will be a tension at this point of contact along the right hand side. And since this hole will be going along the right hand side with some acceleration A. Try to find the value of tension. Mariam, just check your calculation. Sabita, just check your calculation. Let's say for 1 kg block, acceleration of system is, in which direction this block is going. So you will say along right hand side. So 10 Newton will be larger than tension. So it will be 10 minus T divided by mass of block. As acceleration is 3, so 3 into 1, 3. So you'll get T is equals to 10 minus 3 as 7 Newton. Mariam, you have done mistake at this point.
Yes, sir.
Similarly, if you do the same process for this 2 kg block, acceleration of system is, since acceleration along right hand side, so T will be larger than 1. So T minus 1 divided by mass 2. Acceleration is 3, so 3 into 2, 6. Minus 1 on moving to the other side, it will become plus 1. So you will get 6 plus 1 as 7 Newton. Okay, Sabita?
Yes, sir.
So from this, you will say, if string is massless and inextensible, then tension will be seen at each point. So you don't have to calculate at each point, just calculate at any one of them. Safan, is it clear till this part? Aisha? You all have written?
Yes, sir.
Yes, sir.
Three blocks, 1 kg, 3 kg, and 2 kg are connected by two different strings. So tension will be different in different string. Are acted along this direction by a force of 10 Newton, and along this direction, force of 4 Newton. Try to find tension in each string. Let's say tension will be T1 in this and T2 in this. Find the value of T1 and T2. First, take this whole system as single body. So there is a force along this direction of force Newton and 10 Newton along this direction. 1 plus 3, 4 plus 2, 6. So total mass will be 6 kg. Since 10 is in larger in magnitude, so net acceleration will be along this direction as a system. So apply second law. Net force by total mass. Then draw FBD to each block to find tension in each duct. Try to find the value of T1 and T2. Mariam, just check your calculation. Good, Samara. Try to find T1. Good, Mariam. Good, Samara. As we have net force 10 minus 4 divided by total mass 6. So 10 minus 4 is 6, divided by 6, you will get 1 meter per second square. Now put this value in any of these system, you'll get the value of tension. Let's say in this 2 kg block, acceleration of system is equals to 10 minus T1 divided by mass. A is 1, so 1 into 2 equals to 10 minus T1. So T1 will be 10 minus 2, that will be 8 Newton. Similarly, apply in this 1 kg block, or you may apply in 3 kg block. So acceleration of system equals to T2 minus 4 divided by mass 1. Acceleration is 1, so 1 into 1. This minus 4 moving to the other side will become plus 4 is equals to T2. So T2 will be 5 Newton. Is it clear? Aisha?
Yes, sir.
Safan?
Yes, sir.
Sabita, any doubt?
No, sir.
You all have written till this part?
Yes, sir.
Aisha?
Yes, sir.
Now the next concept is pulley system. So first of all, what do you mean by pulley? Pulley is nothing but a circular disc, but in this chapter, we consider it as massless, immovable, and frictionless. So pulley is a massless, immovable, means irrotational, and frictionless. Circular disc. Now suppose you have to find tension and acceleration for pulley-based problem. Suppose you have pulley which is hanged by any support. There is string along this direction and along this direction, on which two blocks, let's say mass M1 and M2 are attached. Is it clear? So you have to find acceleration and tension for this system. Do you have any doubt till this part in this diagram?
No, sir.
Now, first try to check which of these two masses is heavier. So let's say M2 is greater than M1. Now try to draw the value of tension in each point of contact. at each point of contact. So if you draw tension at each point of contact, let's say for this point of contact, it will be in upward direction, T. At this point of junction, it will be along this direction. At this point of junction, it will be along this direction. And at this point of junction, it will be along this direction. You'll observe tension for each block is same. So if tension is same for each block, it means block will move with the same acceleration, but it will be in opposite direction. So M2, let's say, is going along downward as M2 is heavier as compared to M1. So M1 must be going up with same acceleration A. So just remember, displacement of block, acceleration of each block, inversely proportional to tension. Now I defined acceleration of M1 and M2 and its direction. Now we have to draw FBD for each block system. And then on the basis of that, we may write equation according to second law. So let's say for M1, there is a force due to gravity, mg. There is a tension due to its straightness of string, T in upward direction. And this is going up by some acceleration A. So which of these two forces will be larger in magnitude, tension or M1? So you will say as acceleration is along upward direction, so upward force will be larger in magnitude. So using second law, you may write net acceleration is equals to net force divided by total mass. Now move this M1 to the other side, you will get M1A equals to T minus M1G. This will be your first equation. Is it clear?
Yes, sir.
Safan, is it clear till this part? Let me define you once again. So for any problem, first try to define which of the block is heavier or in which direction this motion is going on. So in this part, M2 is greater than M1. So there will be downward motion of M2 and upward motion of M1. Now the next term is to define is the acceleration of each block is same or different. So just remember this. If displacement, acceleration, these two should be proportional to each other, and it should be inversely proportional with tension at the point of contact. So try to draw tension at each point of contact or junction. So I've drawn T at this point, T at this point, T at this point, and T at this point. So just compare the tension of M1 or at the point of contact for M1 and M2. They are equal. So you will say acceleration for each block must be equal. Is it clear? Sabita?
Yes, sir.
Now, draw FBD for each body. So for M1, there will be a force by gravity in downward direction, M1G, and tension in upward direction, T. As M1 is going up with some acceleration A, it means T will be larger in magnitude as compared to M1G. So apply second law, A net equals to net force divided by mass. So move this mass to the other side, you will get m1a equals to T minus m1g. Similarly, if you apply for the second block, mass m2, there is a tension in upward direction, force of gravity in downward direction, and this whole term is going down with some acceleration a. So which of these two forces will be larger in magnitude? So you will say m2g, as acceleration is along down direction. So A equals to net force by mass of the block. So move this m to the other side, you will get m2A equals to m1g minus t. So this will be your second equation. Aisha, is it clear? Samira?
Yes, sir, clear.
Okay. Now add these two equations, you will get the value of acceleration. And on dividing these two equations, you will get the value of tension. So first, add these two equations. Try to find the value of acceleration. So Myra, just check your calculation. Mariam, check your calculation. Oh, just write M2 here. If you add these two equations, T and T will cancel out. If you take out A as common, M1 plus M2 equals to M2 minus M1 times G. So from this, acceleration will be M2 minus M1 divided by M1 plus M2 times gravity. Now, if you put this value in any of the above two equation, you'll get the value of tension. Or if you divide equation first and equation second, M1A divided by M2A equals to T minus M1G divided by M2G minus T. This A and A will cancel out. So on cross multiplication, move T term to one side and rest of the term to other side. So you will get 2 times of M1 M2G equals to so tension from this will be 2 times of M1 M2 divided by M1 plus M2. So Myra, is it clear?
Yes, sir.
Aisha, any doubt? Okay. Just write it down to this part.
Done, sir.
So,
Done.
Safan,
Yes, sir.
any doubt?
No, sir.
Now take M1 to be 4 kg and M2 to be 6 kg. Value of gravity to be 10 meter per second square. Find acceleration and tension for the above case. Try to find. There is gravity in the term of tension. Sabita? Okay. Safan, send me your answer. Aisha? Mariam, just check your calculation.
Sir, I'm doing.
Good, Mariam. Good, Samara. M2 is 6, M1 is 4, divide by 4 plus 6 multiplied by G, which is 10. So 4 plus 6, it will be 10. So this 10 and this 10 will cancel out. So 6 minus 4, it will be 2 meter per second squared. Now, if you put in this second part, M1 is 4, M2 is 6, divide by M1, which is 4 plus 6 times gravity, which is 10. So 2 into 4, 8 into 6, 48 into 10, divide by 10. So this 10 and this 10 will cancel out. So you'll get just 48 Newton. Aisha, check your calculation.
Yes, sir, I did mistake. I got it.
Safan, any doubt?
No, sir.
You all have written?
Yes, sir.
Suppose there is a horizontal surface and a pulley at this corner. There is a string which pass like this. So you have to find acceleration and tension for this. Suppose M1 will be responsible for causing acceleration for this whole system. So it will be along this. And there will be acceleration at this point along this. Now draw FBD of each block and write the equation and then simplify it to get your answer. Try to solve. You have to find your expression in terms of M1 and M2 as well. Similar to what I have done in the above part. Let's say for M2, there will be a tension along this direction, and there is no any force opposite to its motion, due to which it will be accelerating along this direction. Mass is M2. So using this, you may write A is equals to accelerating force is only tension, mass is M2. So T will be M times A. So this will be our first equation. If you draw for M2, M1, there will be a force in downward direction, M1G, tension in upward direction, T, and this whole will be going along downward direction by some acceleration A. So acceleration will be M1G minus T divided by M1. So from this, you may write M1A equals to M1G minus T. Now we have two different equations. Put the value of T from first equation in this part and simplify it. You'll get the value of acceleration. Try to find. You may add these two equations to get acceleration like this. If you add these two equations, take A as common, m1 plus m2, t and t will cancel out, so m1 times g. So A will be m1 times g divided by m1 plus m2. So this will be your acceleration. Now, if you put this value of A in first equation, you will get tension equals to m1 m2 times g divided by m1 plus m2. Is it clear?
Yes, sir.
Sabita, is it clear?
Yes, sir.
So for these type of problem, you have to derive the value of acceleration and tension with related with m1 and m2 and g, and then you have to put the values. Okay. Safan, is it clear?
Yes, sir.
You all have written?
Yes, sir.
Yes, sir.
Aisha?
Yes, sir.
Okay. Oh, so let's stop here. There is some inconvenience. I will continue in next class. Okay.
Okay, sir. Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.